The purpose of this video is to introduce you to the Texas Instruments BA2 Plus calculator and talk a little bit about how to use the calculator for some basic time value money problems, specifically what I refer to as the 5-key approach. Before we do that though, I do want to just introduce the calculator a little bit and show a couple things with it. Here is your Texas Instruments BA2 Plus calculator. And the time value of money keys are primarily here on the second and third rows of your calculator. There are a few other things that we'll introduce later on that aren't on those rows, but most of the things you'll do for time value of money are up there, as well as the up arrow and down arrow keys from the very top row. Go ahead and turn the calculator on. One of the first things you'll notice is the calculator here is set to 2 decimal places. That's kind of a default setting, and it's a financial calculator, so most people want to see dollars and cents on there, and so that's why it automatically defaults to rounding to 2 decimal places. However, there are lots of things you might want to do where you want more than 2 decimal places, and this is going to force round off to 2 decimal places. So one way to avoid that is to change the number of decimals displayed. The Texas Instruments BA2 Plus displays up to 8 decimal places. What I like to do is set it to that maximum display, figuring I can always round off on my own, and that way if I want fewer than 8 decimal places, I can round off. If I want to see more decimal places, they're there for me. So to change that, you want to use this format key on your calculator. Now notice the format is a shift function, so you have to start with the second key. Go ahead, press second, format, and now your on-screen display you'll see DEC equals 2. That's saying the number of decimals right now is 2. We want to set that to 8, so we're just going to press 8. And then this enter key. Enter. And we'll go ahead and hit the clear cancel a couple times. And now you can see it displays far more decimal places for us. So that's one of the first things we're going to set up. Another thing that I want to introduce real quick is a time value of money function that we'll use a lot in this class, and that's setting the periods per year. Now a lot of things we do are set at 1 period per year, annual, but you might also encounter something like a mortgage payment where you want 12 periods per year. You might want to look at saving for retirement where money gets pulled out of your biweekly paycheck, 26 periods per year. You might want to do something with daily, 365 periods per year. So lots of different situations where you might change that periods per year. The periods per year key is again a shift. It's this P/Y here, shift of the I/Y key. And as we go ahead and press second P/Y, you'll see right now our calculator is set to 1 period per year. Now to change that, you just decide what you want it to be. For example, if I want weekly, that would be 52 periods per year. So just press 52 and then go up here and press the enter. You do have to press the enter for that to register. So press the enter, clear cancel a couple times, and now your calculator is at 52 periods per year. Now when you turn your calculator off and back on, it's still going to be at 52 periods per year. So remember, the only way to change that is to actually go in and change it. You can't just turn your calculator off. You have to go in and change your periods per year. So right now I'm going to set that back to 1 because that's what we're going to start with, annual 1 period per year. So again, second P/Y brings up the on-screen display that tells us we're currently set for weekly compounding. I want that to be 1 period per year. Enter, and then go ahead and hit clear cancel a couple times, and now we're set to 1 period per year. Now the other thing is something we're not going to use very often in class, but I do want to show you, and when we introduce annuities, annuities are when we have equal periodic cash flows like a mortgage payment or a car payment or a monthly savings plan that we're making. Normally we assume those come at the end of each period, so we're going to save at the end of each week, or we're going to make our monthly mortgage payment at the end of each month, and that's the default assumption. However, you could do those at the beginning of each period. If you do that, you've got to let your calculator know that you're not using the normal end of period assumption, and instead you're using beginning of period assumptions. So in order to do that, we want to change our calculator to begin. And you can see the BGN function here is a shift function again. So we have to do second BGN. Now what that'll do is bring up our on-screen display, and you can see right now that says end. We want it to be set to begin, and to change that we have to use the set command. So set toggles back and forth. Second, set. Each time I press second, set, you see it toggles back and forth. When it's on begin, also note up here in the right hand corner, you'll see BGN on your screen. So once you have that set where you want it to be, press enter and clear cancel a couple times. Now notice up in that right hand corner you have the BGN still up there. Now your calculator is using beginning of period payments. So let's go ahead and change that back. Again, second BGN to enter the module to switch back and forth. Once you're in the module, second set toggles you back and forth. Every time you do that, it just switches back and forth. We want it to be end, so when it's at end, notice now that's cleared off the right hand corner. Press enter, clear cancel. Now our calculator is all set up and ready to go. So now let's look at a basic time value of money problem. You deposit $7,000 into the bank today and earn a 6.5% rate of return, or interest rate, on your deposit. Now oftentimes we'll use the terms rate of return and interest rate somewhat interchangeably. Technically there's a slight difference. An interest rate is usually something that's paid on debt. When you borrow money or you lend somebody money, there's going to be a rate of interest associated with that. Other types of investments like stocks or precious metals or commodities or things like that often have a rate of return because it's not a constant promised rate. However, in class, the rate of return or interest rate is often going to be our discount rate that we use in our 5-key approach. So that's another term to get used to, discount rate. So you deposit $7,000 into the bank today, earn a 6.5% rate of return or interest rate on your deposit. How much will you have after 15 years, assuming annual compounding? Now remember, our calculator is already set to annual periods, 1 period per year, and what we're going to use now is this 5-key approach. And notice your 5 keys. N, that's the number of periods. I/Y is your rate of return or interest rate or discount rate. PV stands for present value. PMT is an annuity stream. We actually don't have one in this problem. And FV is your future value, what your money's going to grow to over time. So in this problem, we start with $7,000 that we're depositing into the bank today. So that's going to be our present value. The 6.5% rate of return is our interest rate. 15 years is our N, and we want to know how much we're going to have after that 15 years, so we're solving for our future value. So to do that on the calculator, we always want to put the value in and then enter it into the key. So let's just start and work our way across from left to right, and we're going to start with the number of periods. Our number of periods, remember, is 15 years. So 15 is our N. Our 6.5% rate of return is our interest rate. So it's going to be 6.5 I/Y. Our present value is the $7,000 that we're putting into the bank today. 7,000 PV. Now we don't have an annuity stream here yet, so we're just going to zero that out. Our payment, PMT, represents any annuity stream, so we're just going to put a 0 there, and then we're going to solve for our future value. Now whenever you're doing the Texas Instruments BA2 Plus, in order to solve for the key that you want, you have to press compute, a CPT button. So let me walk through that on the calculator. We want to start with our 15N. So we just put in 15, press the N button. Then we want to go to our 6.5% interest rate. So enter 6.5. See that on the screen there. Press the I/Y. And now that's entered as our interest rate. 7,000 is our present value. So let's go ahead and get that into the calculator. 7,000. Press the PV button. We're not using the annuity stream, but we want to make sure the calculator doesn't have anything in there, so we want to zero that out. So just 0 and press that PMT. Now the last thing we're going to do is solve for our future value. We need to compute that. The compute is up here in the corner. See that CPT? You want to press that first. Once you've pressed compute, then go down to the future value. Press that and you'll get your answer, $18,002.89. So let me just write that down. $18,002.89. Now one thing to notice on there, if you look closely, you'll see your answer actually comes out as a negative value. You have a negative sign there in front of the 18. What that is doing is the calculator is trying to balance things out. You originally said you received 7,000. You made it positive. That was a cash inflow. So we're actually looking at this from the perspective of the bank. The bank got your 7,000. It had to give you back 18,000. So the bank received 7,000. It paid back 18,000. Now, we didn't worry about which direction things were going in this problem because we know whether we are us or the bank, and we know if we give up 7,000, we're going to get back 18,000. So I didn't make it negative. Now the rule here, and we'll talk about this more as we move through, but anytime you have 2 or more of your cash flow keys, present value, payment, our future value, any time 2 or more of those have non-zero inputs, you have to watch out for the signs. In this case, we have 1 non-zero input, so we don't have to worry about the sign. But a little bit later on, we'll get to some examples where we do have to worry about that. Let's go to another example. Okay, now you're saving for retirement. You want to save $4,000 per year. That $4,000 per year, key part there is where you see that per year. That tells us we're dealing with an annuity. We're going to be using our PMT button here. Per year means annuity. Anytime you see per year or per month or each year or every year, something like that, where you know you have the same cash flow every year for a fixed number of years, you're dealing with an annuity. Got 25-year time horizon here, so N is going to be 25. Got an 8% return. So that's our I/Y. How much will you have at the end of the 25 years? So we're trying to figure out how much we're going to have after 25 years. We're solving for a future value. So again, our N is going to be 25. 8% is our interest. We don't have a present value in this problem. We're not starting with anything, so we're going to zero out the present value. Our payment is the $4,000 per year. Now again, note, we're only entering one non-zero value for one of our cash flows. Present value, payment, and future value are our cash flow buttons, and we're only inputting two of those, present value and payment, solving for the third one, solving for future value. But present value is 0, so we're only entering one non-zero value. And then we're going to compute our future value. So let's go ahead to the financial calculator. Clear out a couple times so we're staring at our blank screen again. And again, we're going to be using our 5-key approach. Our N was 25. So we just put in 25. Press the N. 8 was our interest per year. So let's press 8. And then go up here to the interest per year. 0 present value. So 0 PV. 4,000 payment. And notice as we press these buttons, the on-screen display tells us what we're putting in there. And now the last thing we want to do is solve for our future value. Remember, we have to press the compute button first. So CPT, FV, and that gives us our answer, $292,423.76. So after 25 years of saving $4,000 per year, earning an 8% rate of return, we're going to end up with a little under $300,000. We're going to have $292,423.76. Now we're going to make a slight change. What if instead of starting with nothing, we started with $25,000 already? So we already have $25,000 saved. We already have $50,000 saved. We still want 25 years. So now, again, let's go ahead and look at our 5 keys. Again, we're going to be solving for future value. We have 25 years, so that's going to be our N. Our interest rate is still the 8% from last time. We're just changing the fact that we've got $50,000 already saved. So we still have an 8% interest rate. Our present value is $50,000. Our payment is still the $4,000 per year. And now we want to know the future value. Now here we have 2 or more non-zero values. Now it becomes important that we make sure that the cash flow direction is correct. Now we can look at this from our perspective where we're giving that money up, or the bank's perspective where they're getting that money today and then they're going to have to give something up later. Let's go ahead and look at it from our perspective. If you have saved $50,000 today, you've given up that money. So it's going to be a cash outflow and you want to make it negative. You're also going to be giving up $4,000 per year. So we're going to make that negative. Now when we solve for this, since we gave these values up now, we're going to get back a certain amount at the end. So our answer is going to be positive this time. So let's go to our calculator. Again, clear cancel a couple times so we're starting fresh. Going to be using that 5-key approach here. And let's go ahead and start with our N. We have 25N. Let's go ahead and put that in. Our interest rate is the 8%. 8 I/Y. Now our present value is 50,000 and it's negative 50,000. So let's take a look at that. Let's put in 50,000, but now we need that to be negative. So what we need to use is our plus minus key on our calculator. Down here you can see the plus minus. Don't use your subtract key. That's not what you want. You want to use this plus minus to change it. So once we put in the 50,000, press this plus minus key. Now you can see that's negative 50,000. That's what we want to put into our present value. Negative 4,000 for our payment. So again, 4,000. Make it negative. See, that's a negative 4,000. Press our payment. Now we're ready to solve. Compute future value. Notice our answer here comes out positive. $634,847.52. So having that extra 50,000 today generated us quite a bit more money at the end of the 25-year time frame. Next thing we're going to look at is we're going to start with $17,400, or take that back. We're offered $17,400 in 8 years in exchange for $9,500 today. So in effect, what we're doing is lending money, giving up the $9,500 today in exchange for $17,400 8 years from now. So we're going to be solving for the interest rate. So again, 5-key approach. N I/Y PV PMT FV. But now we're solving for this interest rate here instead of for the future value. So our N is the 8 years. Our present value is what we're lending today. Now we're giving that money up, so that's going to be negative $9,500. Giving that up, so it's got to be a cash outflow. There is no annuity stream here, so we can zero out the payment. And our future value is the $17,400 we're going to be receiving 8 years from now. $17,400, and then we're going to compute our interest per year. So let's walk through that. Again, clear it out. 8N, negative 9,500 present value, 0 payment, 17,400 future value, compute interest per year. Let's go ahead and put those in. 8N, 9,500, make it negative, present value, 0 out the payment, 17,400 future value, and now we want to solve for our interest per year, so we do compute I/Y, and we get 7.86% as the interest rate on the loan. Now one thing I want to note real quick, what if I wouldn't have made this 9,500 negative? Let me just redo that real quick and show you. So we're going to have 8N, 9,500 present value, 0 out the payment, 17,400 future value, compute the interest, and you get an error message. Reason is there's no solution. The calculator is trying to find out how you can get 9,500 today and get 17,400. There's no interest rate that you can come up with that allows you to receive 2 cash flows without ever giving anything up. So that's going to give you an error. If you see an error 5 message on your calculator when you're solving for the interest rate, it should trigger right away. Hey, I forgot to make something negative. So go back and double check your setup. Last one we're going to do today is calculate the payment, but now we're going to change something. Instead of looking at annual, we're looking at monthly payments. So we're going to have to change our periods per year. We want our calculator to be at 12 periods per year. Hopefully you remember how to do that, but just real quick, we want to go to the P/Y, that's a second function, so second P/Y. That'll ask you what your periods are. Set that to 12. Enter. And go ahead, clear cancel a couple times, clear that out. And now we're ready to put that into our calculator. Another thing we have to be careful about is, remember, N is not necessarily the number of years, it's the number of periods. So if we're dealing with monthly payments, we have 12 months per year times 5 years. It's going to give us 60 months. So a 5-year car loan is not 5N, it's 60N. Our periods per year is set to 12, so our N has to be the number of periods. So 60N. Our interest rate, we're borrowing at 3.9%. So 3.9 is our I/Y. PV, here's another tricky part. A lot of times people see, well, we've got $5,000 for the down payment. That's what we're paying today. But that's not relevant. What's important is we're borrowing money today and we've got to pay that money back. So our present value is always, how much are you borrowing today? This is going to be true for any type of loan, whether it's a car loan or a mortgage loan. Present value represents the amount that you're borrowing. So in this case, our car is going to cost $25,000. We've got $5,000 that we're paying today. So now we want to take that $25,000, subtract out the $5,000 down payment, and that's going to leave us with a present value of $20,000. That's how much we're borrowing today. Our PMT is what we're trying to figure out, so we're going to compute that. And our future value represents how much we owe at the end of the loan. At the end of the loan, it's paid off, so that's zero future value. Now let's go ahead and put that into our calculator. Remember, the compute is always the last thing, so that's the last thing we want to do. We already set up our periods per year to be 12. So now we want to put in the 60N. Our I/Y is the 3.9%. Our present value was the $20,000 we were borrowing. Remember, the purchase price minus the down payment. So we borrowed $20,000 today in order to buy the car. We don't owe anything after the last payment is made. There's no future value. So zero out the future value. And now we want to solve for our payment. But remember, since we're solving for it, compute PMT, our payment, $367.43. Negative, because they're going to have to pay that. We're receiving the $20,000 today to buy the car. We're going to have to give back $367.43 a month in order to pay off that car loan. That should give you a quick overview of how to use the 5-key approach to solve for time value of money if you're using the Texas Instruments BA2 Plus calculator. Hope this video has been helpful.